Hi, Year 13. I'm going to be going through section 9.7, which is parametric differentiation. So basically what this means is finding dy by dx when you are given your graph or your function in terms of another parameter. Now, parametric equations are all about where you don't get them in the Cartesian form. If you remember, that was named after René Descartes, and he's the one who basically put everything in terms of y and x. Parametric equations are when you get x in terms of another parameter, in this case t, y in terms of the other parameter, again in this case t, and then we need to kind of put them back together effectively. Okay, it's a very, very easy thing to do as long as you remember what it is. Okay, it's not difficult, this in the slightest, I promise. It just looks horrible. Right, this thing up here, as always, what it's saying is that to get your gradient, to get dy by dx, get dy by dt, get dx by dt. So what that means is differentiate y with respect to t, differentiate x with respect to t, and put the y1 over the x1. Okay, this comes from the chain rule. I'll sort of show you it in a second. But if you remember the chain rule, which is where you get one of them, you get the other one, and then you multiply them together so that your dt's effectively cancel out. That's what's going on there. Okay, so the way this works, underneath here, find the gradients at the point P where t equals 2 on this curve. So dx by dt and dy by dt, all they mean is just differentiate this thing with respect to t. So just differentiate this. So that's going to be 3t squared plus 1. And dy by dt will just be 2t, and the 1 will disappear. Okay? So I've got dy by dt, just the top bit up there. I've got dx by dt, which is the bottom bit down there. So you just put this one over this one. So dy by dx is the y1, 2t, over the x1, which is 3t squared plus 1. And that's it. Okay. So differentiate this, and put the y1 over the x1. And we're being asked here, remember, to find the gradients when t equals 2. Okay, now remember that when you're figuring out the gradient, it means that you can give this as an actual answer. This is your gradient function. Your gradient, and we always call m, and that we want this when this is 2. So what we do is we just sub in 2 into this thing. So we're going to do 2 times 2 over 3 times 2 squared plus 1, which is going to give me 4 over 30. So that's my gradient for that one. Okay. Right, example 22 then. Now, it's a little bit trickier this, and this is a bit more like what you'll be asked to do in an exam. Find the equation of the normal. Okay. At the point P, where theta equals pi by 6, to the curve with parametric equations, these things. Okay. Now, just before we kind of get into the dx by d theta and differentiating this and everything like that, remember that when you're doing the equation of the normal, that means that you're going to be using y minus y1 equals m brackets x minus x1, and the m, the gradient that you're using there, is actually going to be minus 1 over m. Remember the negative reciprocal of it, because the normal means that you want the perpendicular gradient. So we'll come back to that later on, but just something to be thinking about. Okay, which means we need a gradient, and we also need a coordinate in there as well, don't we, for the y1 and the x1. But we'll come back to that in a sec. Okay, so let's figure out then our dx by d theta it is this time, isn't it? So 3 sine theta differentiated just goes to cos theta, so that's going to give me 3 cos theta. And dy by d theta will give me 5, but cos theta differentiates to minus sine number, so it'll be minus 5 sine theta. Okay, and then so when I want dy by dx, I want this one over this one, so I'll get minus 5 sine theta over 3 cos theta. Now I can tidy that up. Okay, from there we're going to be subbing in theta and using this to figure these things out. But if I can tidy anything up as I go along, that's important when you're doing this, because this I'm not going to lie, this one especially gets quite complicated and quite horrible later on. So if we can tidy anything up here, then we should be doing it. Can you spot what it is that I'm talking about? Look at this, sine over cos. What does that simplify to? So we can simplify that to minus 5 over 3 tan theta, which means that that looks a little bit nicer. Okay. So if I want to turn that into the actual gradient of the curve at the point P, it means I'm going to sub in pi by 6. So m will be minus 5 over 3 tan of pi by 6. Okay. Now, subbing that in will give me an answer of minus 5 root 3 over 9. And put that into your calculator. Okay. Remember that the fact that we've got this pi by 6 means we're dealing in radians. If you put that into your calculator and got something different. Okay. Now, that is the actual gradient of the curve at the point P. We want to be working with the normal, so we want the perpendicular gradient to this one. So the gradient to the normal will be the negative reciprocal of this. So that's going to turn positive and it's going to flip upside down. So it's going to give me 9 over 5 root 3. Okay, there is something there that I don't like. Can anyone spot what it is? I don't know, I'm asking that to video with me. You've got a root on the bottom. You don't like that. So we're going to rationalize this. Now you can't just shove that in your calculator and it'll do it for you, but effectively what we're going to do is multiply both the top and the bottom there by root 3. Okay, so that will give me 9 root 3 over 5 times root 3 times root 3. Root 3 times root 3 is just 3. That's going to give me 9 root 3 over 15. And that can simplify. I can cancel the 3 out of both of them, which is going to give me 3 root 3 over 5 is the gradient that I'm going to use. Okay, so at the minute, in terms of the normal, I know what the gradient is. I do not at the minute have a y1 or an x1 though, so I have to think, well, where is that going to come from? Well, where in the information that we've got given have we got a link to tell me what x is and what y is? It's there, isn't it? Okay, so to figure out your coordinate, I have a value for theta. If I want a coordinate at that value for theta, I just sub that value for theta into there and there. Okay, so x is going to be 3 sine pi by 6. Plug that into your calculator, you're going to get 3 over 2. And y is going to be 5 cos pi by 6. And if you sub that in your calculator, you're going to get 5 root 3 all over 2. Okay, so effectively the coordinate at that point is 3 over 2, 5 root 3 over 2, and there's the gradient. So I now have everything I need to be able to use this. Okay, I know it looks horrible. We just have to get on with it basically. Okay, so in terms of y minus y1, that's y1. So my equation starts off looking like this: y minus 5 root 3 over 2 equals the gradient, which is 3 root 3 over 5, brackets x minus x1. Okay. Now, if that was the exam question, you could, if you wanted to, leave it like that. That's it, done. Okay. We now have an equation of the normal at the point P with those parametric equations. I'm just going to multiply this out and just tidy it up a little bit. Okay. So y minus 5 root 3 over 2 will equal 3 root 3 over 5x minus this times this, which is going to be 9 root 3 over 10. I'm then going to multiply everything by 10. Okay, just to get rid of all the fractions. So that's going to give me 10y minus, I times this by 10, it's going to be 50 there divided by 2, which is 25 root 3 equals 30 root 3 divided by 5, which will give me 6 root 3x. Minus, and times this by 10, we'll just cancel the 10, so 9 root 3. Okay. Now what I'm going to do is have a little look. There's my y term, there's my x term, so I can group these two things together. So I'm going to bring that minus 25 root 3 over to this side. Minus 9 add 25 will give me plus 16 root 3, and then I can just half all the coefficients. So 5y equals 3 root 3x plus 8 root 3. And if I wanted to turn that into y equals mx plus c, I can then actually divide them all by 5, couldn't I? So y equals 3 root 3 over 5x plus 8 root 3 over 5. Okay, so the main, I mean, this part here, like obviously that's, you had actually finished there, that's the equation. This is just multiplying it all out and tidying it up a little bit just in case you need to use it. You know, you can now see what the gradient is, and you can also see what the y-intercept is and stuff like that. The main part of this is being able to get dy by dx from the parametric equations, and then obviously also get the two coordinates, your x and your y coordinate using the parametric equations, get your gradient, and then sort of put it all together. Okay, so what I'd like you to do is on exercise 9G, I want you to do question 1A, G, J, and M. The reason I put a star next to that is because if you look at what you're starting with there, 2t over 1 plus t squared, when you differentiate something like that, you have to use the quotient rule. Okay, same for that one. I then want you to have a go at doing 2A, 3A, and all of question 5, please. Okay, I will include in the classrooms thing the link to the solution bank for this, so if you do need help with it, obviously you can email either myself, Miss Bloxham, or Miss Cowlett, and we can help you with this, or you can use that. Okay, good luck, and as I say, any issues, just let us know.